Now this one is a typical quartic curve, which really means the highest power is x to the power 4. It has two minimum points, here, and one maximum point. Now at the moment it doesn't cross the x-axis at all, so we would say that this has no real zeros. So I'm going to move it down like this. So now it has 4 zeros. It crosses -2, -1, +1, +2. And this is its equation here. Now watch what happens as I move this point to the right and I move this point to the left. Now the curve still has 4 zeros, but these two are getting closer together and these two are getting closer together, and they're going to coincide at +1 and at -1. Like that. Now the curve seems to have only 2 zeros, -1 and +1, but each one is a double zero. The equation of this curve now is this here. Now I'm going to move this point down and see what happens. Now the function now has 4 zeros again, 1, 2, 3, 4. But these 3 points are going to coincide at the origin, like this. Now the function has 3 zeros, 1, 2, 3. But this is the place where 2 of the points coincided, so that's called a double zero as well. Now I'm going to move these 2 points towards x equals 0, like this. And now we have the very, very basic quartic curve, which is just y equals x to the power 4, which is not a parabola. It's got a very flat bottom, this one. Now I'm going to add in an x squared term like this. X squared times x squared plus 1 is really x to the 4 plus x squared. Like that. And finally, I'm going to add a 1 to this term to make it x squared plus 1 squared. Now it's hardly recognizable as a quartic curve anymore. In fact, it looks quite like a parabola, but it's not. It's still a quartic curve.